Hello everyone, my name is Terrence Hall, and this is a video demonstration of my Lab02 SwitchCounter for the Basis 3 board for my CPE 3020 class. The purpose of this lab is to count the number of active switches on the board and turn on the LEDs equal to that number and show it on the onboard 8-segment display. Starting off by looking at the wrapper, I have it configured to look at the 8 rightmost switches and LEDs. I'm just using 7 segments of the 8-segment display, ignoring the last one, that just being the period. And this indicates the anode used to turn on the 4 onboard 8-segment displays. Going further down, the anodes read as 1 being off and zeros being on. With the rightmost digit being 0 here, it indicates that the rightmost LED display will be active. Going more into design, I have the signals imported here under the switch counter. These are the same names as indicated before for the wrapper, or from the wrapper, I mean. I have constants for indicating what I intend to display on the 8-segment display. We're just going to be using the values 0 through 8 for the purpose of this lab. Going a little bit further down, looking at the switch counter. Uh, this counts the number of active switches by checking each of the 8 bits in the switch vector and stores it into the integer here, into the integer count. And depending on that count, it goes through a case statement and assigns a value for the switch counter provided. And the switch counter, this essentially drives the rest of the drivers on the rest of the code. So depending on what the output of the switch count is here, that's dependent on which LEDs are going to be active. And it goes up by 1 increment, and these are all vectors, so they go up accordingly. Same for the segment display drivers, since I labeled the constants here rather than leaving out the vector here. I can simply just write out the name shown here. To test my logic, we'll be looking at the test bench. Since we're going to be using 8 switches, that essentially means that there's 8 variables, and if you were to put that into a truth table, you would do 2 to the power of 8 to see all the possible combinations. It's being 8 because there's 8 changing variables, and 2 to the power of 8 is 256. It's probably not necessary to look at all of the 256 possible combinations, but if the point of a test bench is to look at all those combinations, I went ahead and did every possible combination uh, that's possible for this lab. And even though it is a long line of code, it runs pretty fast whenever you're doing the simulation. And let's run the simulation to check to see if the logic that I have runs correctly. Sure, save. Now we're not going to go through every single possible combination, obviously. We'll just kind of look through the main ones, or the or the obvious changes, I mean. Let's get this lined up. Okay. First possible output. I have all the vectors being read in, the switches, the LEDs, and the board segments. The board segments read as inverse, so 0 is indicating active and 1's reading as inactive. For this case, none of the switches are active, so the number should be 0. Therefore, none of the LEDs should be on, which is correct so far. And the 7 segment display, It's only showing that one active here, but like I said, it reads inverse, and this last one is the one, or is the segment that's in the middle, which is G. If you were to be looking at a 7 segment display, showing the different numbers shown on there, which is what I'm looking at, just to make sure I'm reading it correctly, since it's not on the board. So far so good. We'll just look at the next possible combination. With the one switch being active, in this case is going to be switch 4. One LED is on, so that should be correct. And looking at 1, this is off, off, off. And these two being B and C of the 7 segment display. So far that is correct. These are the two possible outputs. So 2 switches on, 2 LEDs active. Yep, and 2 of these being active here. So this would be the top left one being not off, or not on, I mean, and then the bottom right one being not off. So it should be displaying 2 here. And then let's look at the next combination of 3. 3 switches on, 3 LEDs on, and then this being the top left and the top right not on, indicating the 3 on the 8 segment display. This is still 3. 1, 2, 3. Yep. Oh yeah, I also need to do this because it's not going to show all of the possible combinations. Yeah, and it doesn't show all the possible combinations because it just runs out of time, or the limit is it doesn't have time to run all of the possible combinations. So I just extended the time so that we're able to see all of the possible combinations. With this one being 4 switches active, 4 LEDs active. Nice. And 4 should be displayed with the ones being active here. This shows that the top 8 segment is off, the bottom left and the most bottom one is off. So it would be displaying a 4. Next combination. 1, 2, yeah, it's still 4. Guess this is the downside of putting every single possible combination. It just seems like a never-ending simulation. So next one, 1, 2, 3, 4, 5, 5 switches. 1, 2, 3, 4, 5, 5 LEDs. And if a 5 were displayed, only 2 of those 8 segments would be inactive, which is B and E. So this is correct so far. Two, three, four, it's still 5. And this is 6 displays. 1, 2, 3, 4, 5, 6. 6 switches. 1, 2, 3, 4, 5, 6. 6 LEDs. And with the 6, there's only one that's inactive, and that's the top right, which is also B. It shows 1 here. So just correct there as well. It's still 6. 7. 1, 2, 3, 4, 5. Oh crap, still 6. Okay, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 LEDs. And with the 7, One, two, three, four. 4 of the LEDs should be off, which is the top left, the bottom right, the middle, and the bottom. So this is correct so far. And then the last one is 8. All switches active, all LEDs on, and all LEDs are active. So the next video I'll be displaying the outputs on the proto board itself. Thank you for watching.
Hello everyone, this is Terrence Hall again. This is my part 2 video for my Lab02 SwitchCounter for the Basis 3 board for my CPE 3020 class. And again, to reiterate, the purpose of this lab is to count the number of active switches on the board and turn on the LEDs equal to that number and show them on the onboard LED display. I already have it downloaded on here, so we'll just start going through the possible combinations. So first possible combination, none of the switches are active, so the board should be displaying 0 and the LEDs shouldn't be lighting up. First switch active, LEDs active, displays 1 here. Just to show that we actually did all the possible combinations, not just reading from bottom to the top. We'll just do a random one for the next. Second LED, number 2 is displayed on the LED display. 3 as well. Next LED, 3 is displayed. 4, and let's just go down as well. So 3 still shows here. 3 LEDs, 3 switches active. Switch number 4 is active, so 4 LEDs show, and then 4 is shown on the segment display. 5, 6, 7, and 8. And then nothing changes from these other ones because we don't have those initiated on the code, nor do we have it used in the master file as well to make those switches even do anything. So going back down, 7, and we'll just do them randomly. Let's not break the board now. And I hope that was a good demonstration, and thank you for watching.